Hello, the purpose of this YouTube video tutorial is to walk through the COG Lens Visual Occlusion Glasses software for completing NHTSA style testing using the visual occlusion technique. When we open up the software, the first thing we'll notice is that it goes out and it begins looking for the device. Once the device is found, the device not connected status will turn to device connected and will turn green. Once a device is connected, configuration information from the device will populate in the configuration information text box. In addition, the edit configuration box will now be clickable. All other buttons are grayed out except for the begin experiment button. So basically at this point we have two options and we get some information about how the device is currently configured and where the current output file is saved. When we begin an experiment, we will be able to go through a save file dialog and select the exact location for our output file, but we'll get to that in just a minute. First, let's walk through the Edit Configuration button. If you click on the Edit Configuration button, a configuration panel will pop up that gives the current configuration information for visual occlusion testing that are loaded up on the glasses. Now, one option that these glasses have that other glasses do not, and our prior glasses did not, was this option to change the LED power. Your glasses likely have LED bars configured above and below the glasses, as can be seen in this little graphic. Now the purpose of those bars is to offset or counteract the loss of light that's associated with the lenses closing, transitioning to their opaque state. Now the lenses are designed to primarily scatter light. However, that is not always what occurs, and some light will be lost. So in order to offset some of this light scattering that is lost due to the opaque state, we actually add some additional outside light during the lens opaque state. And that can be adjusted using the LED power slider there. If you go onto Amazon, you can buy an illuminance meter for about $30 US. And this can be used to adjust the LED power so that the illuminance levels are identical when the glasses are open or closed. Now, other options that we have here are the ability to change the opacity levels of the lenses when they are open or closed. For the most part, standard testing procedure is full opacity during the closed state and full clarity during the open state, so you'll likely never be bothering with those functions. Other than that, we've got a couple of options over here. You can name, create a name for this configuration, and you can change the open time and the close time for the configuration. We're going to change the name to NHTSA for a NHTSA standard occlusion type test with 1500 milliseconds open, 1500 milliseconds closed, and we're going to go ahead and upload that new configuration to the glasses. You may not have noticed, but in the background the configuration information also changed on the main panel. If we close this out, it's a little easier to see that. And now it says config name NHTSA open MS 1500, closed MS 1500, LED power 45%, open opacity 0, and closed opacity 100. So if we're satisfied with that configuration, we can go ahead and begin an experiment. When we click Begin Experiment, we have the option to choose where we want to save our file. I'm going to go ahead and click the desktop, and I'm going to save my file as cats. And once we hit Save, now we have an experiment called cats, and it will save the file to the desktop. Under the Group ID banner, we have the option to change the name of this particular group of trials that we're running within our experiment. We could call this Group 1 or something of the sort. And this group ID will then be saved for each trial to the output file. Okay, so everything else looks good. Let's imagine that our participant sits down. First things first, we're going to want to run them through some practice, show them what the glasses are. You can imagine the participant is holding the glasses in their hand right now while they're cycling open and closed. And they're probably fairly impressed with what's going on there. You're walking them through kind of the way the experiment works, and these can just be sort of cycling in their hands so they can really get comfortable with the way this works. Once you hit Stop Trial, Some information about that practice trial will then be populated in the form of a graph here. And this P, there's a red P in the lower right-hand corner of that graph, and that's to indicate that that's a practice trial. And that carries over to the CSV output file that was just generated on our desktop. If you look back there, we see cats.csv. So one of the nice features about this software is it's continuously updating and saving the files so as to minimize the risk of data loss due to I/O write errors. Okay, so if we want to see, we can come over here to this CATS file, and we can open it up in, say, Excel or whatever else, and we can see over here in column K it says is practice 1, indicating that it is a practice, and then it gives some information about that practice trial. If we close that out and come over here and click this notes icon underneath the bar chart, we get a trial notes dialog box. In there, we could type whatever we wanted. So we could say something like participant failed visual screening or something of the sort, anything at all. Save and close. And then when we go back over here to our cat CSV file, open it up, under notes we see the note for that trial, participant failed visual screening. Okay, so it makes for a really nice and easy, convenient way to keep participant notes associated with the trials. And this becomes especially important as participants make errors during interaction and whatnot. Okay, so let's say we run another practice trial, and now we're sort of showing them, perhaps demonstrating a task that they'll be doing as the glasses are cycling. So they're becoming more and more comfortable with the way this whole procedure works. Okay, so underneath these charts you see mean shutter open time for the group, for all the group of practice trials and all the trials shown up there with that group ID. We can see the mean total shutter open time and the mean shutter closed time for those practice trials. Imagine our participants ready to go now, and we instruct them on their next task, and we begin running a trial. This looks much the same, but you'll notice when we come over here to trial 4, the trial we just ran, the P for practice is not turned on. And if we come over here to our cat CSV file, open it up, we can see that it is not flagged as a practice. However, let's say that that participant during that first trial took a wrong path to solve the problem, whatever that path was, whatever that means. Save and close. Come over here, we can open it up again. Oh, there it is, took a wrong path to solve the problem, close without saving. It's always going to be there. If we go back to trial 1, there's our notes. So the notes are nice and organized, associated with each of the trials. Go back to the cat CSV file, open it up, and there it is, took a wrong path to solve the problem. Okay, so that way we can know that in the future we'll perhaps exclude that trial from our analysis, and we can continue running additional trials. So let's say we do this a few times. We're just going to skip ahead here real quick. And we now have 8 trials. And you can jog back here through the trials with these arrow keys and see the practice trials and the current trials, any notes associated with them, the open shutter and closed shutter time. And we also get, for this group, we get the mean shutter open and mean shutter closed time. Let's say we're done with group 1 now, and that same participant is sitting there, but now they're going to go through the next block of experimentation, perhaps evaluate another function, and we're going to call it group 2. We can run group 2, and they run a few trials, and we come over here, and we can see now that the mean shutter close time and mean shutter open time updated for group 2. All of the graphs are still available, however, so that we can go back and make notes. But if we come into the CSV file, we will see that group 2 under column B is now listed for trials 9 and 10. So you can begin to see what the structure of an experiment would look like as you ran these. Let's make a little note. Let's say crash the simulator. I'm not quite sure what testing you're doing, but we'll pretend that that happened. Save and closed, and we can see that that note carried on. Crash the simulator in column L. Okay, so that's basically how an experiment is run. There have been a lot of exciting changes to this software. We're really excited about the way it works. Um, the new auto detect functionality and the configuration functionality of the hardware is very robust. Um, in addition to the new hardware changes, well, on the software that you're seeing, the hardware itself in the controller box is extremely precise. All this configuration information is uploaded to the controller box itself. And saved directly on there, so that the same configuration will be shown with any computer that the controller box is plugged into. In addition, the new controller box controls all of the timing, so that once a trial is begun, the glasses cycle open and closed using the onboard timing of the controller box, which has been tested to microsecond accuracy. So the timing with respect to telling the lenses to open and close has been dramatically improved. It's incredibly precise, and we feel very good about that. In addition, if you've got the new hardware, that time it takes for the lenses to actually transition from the open to closed states has been improved dramatically. The opacity is also dramatically improved. So overall, the timing, reliability, and accuracy is significantly better with this next version. And what this also means is that if the glasses are plugged into an old computer or a new computer, the timing will work exactly the same way, because the computer itself isn't what's controlling the timing, the hardware is. Another function that I didn't mention, there's a button that ships with the hardware, and that button could be put around your finger, and you can start and stop trials using that button. And that increases accuracy even more as it stops a trial timer directly on the hardware, rather than going through a software interface, then going over USB and then telling the hardware to slow down, to stop. So it's yet another way that timing has been improved. If you have any questions about this new software, please don't hesitate to send me an email, joel@drivingresearch.com, and I will answer as quickly as I can. Thanks.